So, ladies and gentlemen, this is our brand new presentation. It really talks about what HPQ is now going through. We're really into developing innovative silicone solutions. We're going from quartz to high purity silicone to nano silicone. So that's really what HPQ is now focusing about. So this is the regular disclaimer. I would like to thank the shareholder yesterday who made me realize that there was a few English mistakes. Please apologize for my Wabush Shakespearean English. So sometimes I don't, sometimes when it's a regulatory disclaimer like this, I don't really overly bother to read it, but we did modify it and found a few errors. So we appreciate any feedbacks, any comments from investors. Here we go. What is HPQ business model? Well, this is the opportunity we're looking at. Silicone is needed to break. Let me just try to see if I can get you guys out of the way yet. Sorry, because I'd like to be able to see the presentation I'm reading. Okay. So, wait, Patrick, you already got a question?
No, but you want to see,
yeah, no, I'm seeing the full screen. I just had to move you guys to the corner so I could see what
Yeah, same here.
So I just sorry guys, I just moved you guys to the corner. So basically, the opportunity. Silicone is really needed to break lithium-ion batteries limitation, okay? I have two quotes here from people that are in the business. One of them is from the employee number 7 at Tesla and also the founder of Silla Nano. So it's a company that people do Google and they ask questions about nano silicone will come in. Okay, I'm just oh, sorry about this. I'm just hoping the recording is going to work the way I want to. Okay, let me just go. Okay, I'm going the wrong. Yeah, the opportunity. Why am I going? Okay, so this is the opportunity. You can see on the left side of my screen. Okay, it's a representation of why silicone is better. So basically, it's a better volumetric and gravimetric capacity. Fundamentally, what that says is you can put a lot more energy in a battery if you're using silicone as opposed to graphite. Unfortunately, the issue, the challenge, okay, and there is a challenge, it is that, wait, let me just see if I can, okay, let me get you guys out of the way. So the challenge is deployment of silicone and SI battery space challenges, okay? The big one, and that's the one everybody reads about, volumetric expansion. What does that mean? Is when you go through a charge discharge, and this is why we have a representation for everybody to understand. When you go to a charge discharge moment, when you charge the batteries and you discharge it, you charge, there's a cracking that occurs on the outside layer of the silicone, all right? And over time, it keeps sucking up so much lithium that you end up with a barrier where it doesn't work. So although theoretically speaking, silicone is a better material than graphite to do batteries, the issue really is that it has a limited point of view because of that cracking or that volumetric fluctuation, okay? But that doesn't mean it's doomed. What is the solution? Well, the solution is nano silicone SI. One effective strategy is to reduce the active particle size to nanometer range, at which point nano-sized particle can accommodate the significant stress. This is why nano silicones are so important. This is why this is the focus of it, okay? Everybody can do micron-sized material, but a nanometric is much more difficult. So basically, this image is a visual representation of what it is. So if you can make a nanoparticle below 150 nanometers, you're going to have a material that can replace basically graphite in batteries. But the problem is really, and this is where the business advantage for HPQ and its partner PyroGenesis is, as scientists at the University of California, Riverside have been focused on nanosilicone for a while, but it's degrading too quickly, and it's tough and expensive to produce in large quantity. But HPQ, working with world-class technology partner, is developing a nanosilicone pathways. So we're about to start the commercial validation of low-cost processes that can make up to 4N purity silicone. Why is that important? In the battery space, battery manufacturers have a tendency to want a material that's at least 3N purity, right? Traditional silicone is barely 2N, the traditional metallurgic silicone metal. So right now, everybody's using solar grade residue, solar grade material, or electronic grade default. But once you're gonna go into massive quantity, it's not gonna be there. So Because we are able to do up to 4N. That's already an advantage for our first processes. And our second one's converting it to nanosilicon. So fundamentally, HPQ is developing with PyroGenesis, the PUREVAP port reduction reactors, the one we've been talking about for the last 2 years. It's a new scalable, versatile, low capex and OPEX carbothermic process that can make the high purity silicone that the energy storage sector is looking for. And the second one is the PUREVAP nanosilicon reactor, which is a new scalable, versatile, low-cost plasma process that can transform PUREVAP, our silicone, into the less than 200 nanometer spherical nanopowders and nanowires that the guys are looking for. We're also working with Apollon Solar in France to deploy their patented process to produce nanopore silicone powders using the PUREVAP QRR. So what we're looking for is demand for nanoparticles, nanomaterial is going to be very, very high. And we want to be the supplier of choice for all these producers, but some may prefer a porous silicone, nanoporous silicone. Some may prefer a spherical nano. We don't know who's going to win the technology war. I strongly believe that in the price-wise, it's going to be our nano reactor, but we want to be able to offer that to all competitors or to supplier. So basically, this is HPQ implementation plan. So what we're really doing is we're fast-tracking silicone innovation, okay? We've done enough lab scale and proof of concept tests, at least with the QRR and coming around for the nano reactor, to know that we feel very comfortable where we're going. The first reactor, the QRR, is fully funded by a pilot plant and testing program. So that's already one part that's done. We're getting ready to go live and produce nanoscale spherical SI powders and nanowires for the next generation. What's really interesting is that really the project's potential, from our ability to do up 3 to 4N SI to our ability to do nanosilicon, is attracting a lot of interest. And that interest has fundamentally influenced a lot of our development strategy, how we're going to go, we went around for it. So now we're in a position where we can truly present what we want to do. So as I said, the project potential has already generated NDAs with battery manufacturers and advanced material companies. That means we're already at the starting. They know we exist. They know they want our material for testing. So it's now our job to make sure that we deliver it. So we're going to be producing high purity nanoporous silicone powders. We're also going to produce porous silicone metal wafers. So basically, we're going to produce our nano silicone powders with our reactors, and with Apollons, we're going to be producing high purity nanoporous silicone powders and porous silicone wafers for a different technology of batteries. And at the end, we'll be demonstrating that our capacity to transform quartz into silicone metal working. So that's really our game focus. Our plan is really clear. Our primary objective is nano silicone powders and wires. Oh, wrong button. Next one. Quickly, I'm going to go through silicone, the base material overview. Silicone is really one of today's strategic material. It's needed for everything that's renewable energy. It's actually needed in more things than people know. But it does not exist in the pure state. So nobody can become a competitor to us saying they have a deposit of quartz. I'm a competitor of HPQ. You can't. You have to have a process to transform it. So, and right now your choices are traditional processes, which are very expensive, and I'll show why we're more advantageous, or you're gonna have our new process. The industry right now is going through a flux because it's not very flexible. It's really a 1960, 1970, 1980 type of industry. So it's massive smelters and everything else, as opposed to, oops, sorry about this. Okay, so basically as opposed to this, but silicone demand is still seen as going to be 3.8 million ton, worth 10 billion by 2025. And the driving material of silicone demand is going to be what's known as the chemical sector and the electrical vehicle. So this is just to give you a general idea. When we talk about metallurgic grade silicone metal, it's used in aluminum. When we talk about chemical grades, it's in silicones, and in photovoltaic and other type of application will be developed mostly for the EV. Just to remind people, silicone is already, the traditional silicone is already part of the battery space. Aluminum is made to strengthen, silicones use aluminum to strengthen it. It's used, silicones are used in the windshields. And everybody can see that electric vehicle demand is really going to be driving a lot of the demand for what's going on. Next slide. So what is HPQ? What's HPQ's unique strength? It's really that we've been able to build a world-class silicon innovation cluster. Okay, our partnership with technology partner PyroGenesis, we're developing two specific technologies with them: the PUREVAP quartz reduction reactor, which is a patent-pending innovation, and the PUREVAP nano silicon reactor, which is a provisional patent has been filed. So I think a lot of the investors in HPQ also are investors in PyroGenesis, so I don't need to go further everywhere else. For new investors, take a serious look at what PyroGenesis is about. As the CEO of PyroGenesis often mentioned, PyroGenesis has mostly been involved in top 100 companies, basically multi-billion-dollar enterprises partner. We're their only small company that's involved with them, but we have what we think a project that's worth that's going to be worth both of our whiles to develop, which is the silicone and the nano silicone part of the business. What is the first technology? This is the one everybody knows about. We've talked about for a long time. It's called the PUREVAP ORR. It's a scalable, versatile, adaptable process. Fundamentally, what it does, it's the equivalent to going from a mainstream, basically a mainframe computer to a laptop computer in the world of metallurgy. It's a small, adaptable process. And what does that mean? Well, it gives us an incredible advantage. We're scalable by increment of 2,500 metric tons. So it means our first reactor doesn't need to be built, doesn't need to be massive. That is an extremely important factor in the nano silicone business, okay? Because our competitors, if they want to build a new plant, they're stuck with either increasing production by 30,000 metric ton or cutting down for 30,000 metric ton. You can't really fine tune it. You basically have to tune it with an axe. That's really how you fine tune production. So basically, our process is small, flexible, so that's an advantage to the PUREVAP technology. The second one is we're very competitive in a capex way versus competitive process. The matrix that the industry uses is known as the cost per kilogram of annual capacity. If we build a plant with 2 reactors, okay, we have a cost per annual capacity of about $6.22, all right? So with that price already at 5,000, at 5,000 metric ton capacity per year, we match the capex cost of the tier 1 producer, okay, for a fraction of the investment. So the capital investment we need to start our business is going to be 85 to 90% less than everybody else. Second point about that I don't really discuss is that since quartz is a very abundant raw material, that's another saving that we have. We don't need to build a mine for the starting point of everything else. If you're building a plant that's going to have 30,000, you need a 30,000 metric ton, which you're going to basically need about 100,000 metric ton per year of material. Yes, you need a mine to make sure you control your costs. When you have such a small scale process like ours, we can buy our quartz there. That's another massive saving. Just take a look at Nouveau Graphite. They need to build a mine they need to build a $300 million mine for their graphite. And then they have to figure out how to make it into micron-sized spherical powders for batteries. We just eliminate all that need for capital. So that's another advantage of our system. So fundamentally, very competitive. Just to give an example, Mississippi Silicon. It's a subsidiary of the biggest Brazilian company in silicone. They built a new traditional plant in Burnsville, Mississippi, in 2015. And while they had a cheaper capex than the 622 at 611, they had to build a plant with an annual capacity of 36,000 metric tons to get that done. That gives us a massive advantage. The third massive advantage that we have is really on the operating costs. What you have here is just a it's just the presentation of the cost structure for the industry over the last 10 years based on the selling price of the lowest grade silicone. 553 is basically 98% silicone, okay? And you basically see it's a high volume, low margin type of operation. It fluctuates and everything else. And right now our estimations, our operating cost is going to be around between $1,000 and $1,500 a ton, or $1 to $1.05 a kilogram per cost. So that gives us a straight out very, very big advantage in this business. Of course, it will need to be validated when we run up the Gen 3. But this is really one of the ace in the hole that we have in the nano silicon business. I'll go more into detail later. So really, what I've shown you is that the PUREVAP QRR is fundamentally a process that gives us a unique advantage over everybody else, especially as we enter into battery space. And I'll go more into detail. Now the next slide might be more what people would love to have asked me many questions. Where are we? So basically, this is the project milestone and indicative timeline of our PUREVAP reactor. We've done the proof of concept. We've done the scalability test. We've finished all the engineering process refining. We're about to go live with commercialization, which is basically getting the Gen 3 operational, starting to produce 50 tons per year. Getting that done is going to be done now and next year. And then after that, we'll be looking at constructing our first plant, okay? This slide will have to be studied, and I would like people now to go to this slide, which shows the scaling up process, okay? This is what we've been doing it. This is how, when Peter of PyroGenesis keeps saying from the get-go, their philosophy is to have, they think about scalability from the beginning. Well, this is what it is. We start from a proof of concept, we're already thinking commercial plant. It's always how we work. So the first phase we work are usually with some batch processes, then we work into semi-continuous processes. But the point I want people to realize is that if we're talking, if you go back to the price of selling of material, it's selling for about right now $2.05 a kilogram. Just the per silicon metal that's going on. So even if I were to rush my pilot plant operational and we produce 4,000 kilograms per month, we will only be selling it for about what, $8,000, $9,000 a month. And you'll understand why later, why for me the focus is much more on the nano silicon. But the QRR is our case in the hole. It's what differentiates us from all the other players in the nano silicon business. Literally, it's what really gives us a killing advantage. So here we go. Silicon is the graphite killer for lithium-ion batteries. Okay, so all those graphite companies, what we're looking at is replacing silicon. Quickly, it allows for greater energy storage, allows for smaller size batteries for electronic device in cars, energy storage potential. You know, silicon can increase battery charge by 10 times and energy density by 40%. That is massive, okay? That is the holy grail everybody's looking to be able to do. Talking about holy grail, energy storage, a massive market, okay? Demand for renewable energy is part. The biggest problem with renewable energy, its biggest weakness, is that it generates energies when people don't need it. That is literally the problem with renewable energy. So this is why energy storage and public block, all the big people that were there talking about solar power and everything a few years ago started to come to realize that there's a point where there's too much solar power generation capacity and not enough energy storage. So our entry into the nano silicon space for batteries is serendipitous. A, because we're working with Pyro, we have a track record of experience at this, and B, because the market is about to go through stratospheric expansion. We're talking about, you know, by 2040, it's gonna be massive. We're here at almost like the 0 point, and we're gonna be talking, you know, 1,400 kilowatt hours of storage needed. According to them, it's $40 billion in investment just in energy storage. There's other rumors how much money is going to spend in R&D. Right now, this is really the interesting market, and we're coming along with more than one option. So, the key point: energy storage, a massive market for nano silicon. Nano silicon for energy storage is an unexpected positive for HPQ. This is one of my competitors. Okay, the real problem is that can we get a battery that's powerful enough? So nobody's arguing about, is this technologically feasible? The problem that everybody has is, can we make the battery cheap enough to build trillions of them? Right? Just to give you an example, this company, which is trying to do about the same thing we're doing, their pathway they want to use to have cheaper silicon, okay, is to recycle silicon from solar panel. Well, we're doing some studies about recycling silicon for solar panels in our QRR process. And what we've come up as one of the biggest stumbling block is the contamination of the material. So yes, the silicon into it is high purity, but as it's built into a solar panel, there's contamination that comes into it. So we think that our approach is much better. And we know that our approach is much better. But just to give you an idea of the size of the market, 1,000 metric ton of silicon, okay, is barely enough to make lithium-ion batteries that will store 5 gigawatt hours. Go back to the graph on the previous page. By 2040, this is what? This is in 20 years from now. We're talking about a demand of 920,000 metric tons of nano silicon powders. At this stage of the industry, the worldwide capacity to produce it, probably 5 tons, and it sells for $30,000 a kilogram. You're not going to replace graphite if you keep selling at these prices. So it goes back to the argument the guys have probably said. It is cost of manufacturing that is the key of where we're going. So basically, HPQ and PyroGenesis to develop a low-cost process to make nano silicon powder could not have come at a better time, for a better time. Okay, so what is the PUREVAP nano silicon? Okay, in 2019, HPQ asked, AKA, I basically bothered them long enough for them to, no, I'm just joking because we have a very good relationship with PyroGenesis. But I've always been intrigued and always wanted to see, was there a way to basically use their 20 years of experience in plasma atomization to make metal powders and see if we could develop a low-cost process that could transform a PUREVAP QRR into silicone materials battery manufacturer was searching for. These efforts have resulted in the creation of the PUREVAP nano silicon reactor, a new proprietary process being developed by HPQ and PyroGenesis to make the spherical silicone nanopowders and nanowires needed for the next generation. So just a pure quick synopsis, we take our PUREVAP silicone metal, we bring it to the machine, we manufacture nanopowders, okay? I know that many people would like to have more understanding about the JV and how we're gonna develop this. There'll be news, there'll be updates on this coming soon. Fundamentally, PyroGenesis and HPQ work so much hand in hand that sometimes we're more preoccupied with the technical aspect than we are with the legal aspect, but the relationship is good and everything is going in the right direction. So what's really exciting about this? Well, proof of concept test, as I shown before, validated the potential of the PUREVAP nanoreactor. You have to understand that the PUREVAP, the Gen 2 PUREVAP that we used, which was a quart reduction reactor, we ended up using it to try to synthesize, and we were successful at synthesizing, making spherical nanopowders and nanowires from silicon, okay? That is an incredible demonstration the process works. What's been going on since we got those results is we've been, okay, designing what's gonna be our pathways to go from this, to go from this to go to commercial scale. And our discussion with industry participants made us realize that for when we had the original ideas to design it, our plan would have been to take the material, send it to a university, the NRS, which we work with, for them to test it. So when we do those type of tests, we're talking about we need something like, I don't know, 5 grams, 6 grams, 10 grams to do a test, okay? As we started to have discussion with industry participants, we started to realize that these guys are gonna want 100 grams of material up to 1 kilogram on a repeated basis of multiple batches to be able to validate the process. So we had to rethink, or basically advance our thinking, how we're gonna be developed. So we came up with an HPQ and Pyro, came up with basically a 2-phase program. Instead of just focusing on building a new semi-continuous process, we're gonna first start producing nanomaterial by this year so we can learn from the process, okay? Because the key part for us isn't really manufacturing the nanosilicon, it's how you collect them economically. And this is what we're gonna be developing. So basically phase 1 proof of concept's already been done. We're in the design and conversion, everything's been planned, everything is ready to go. So it's gonna be like the assembly of the first generation is gonna be during the next quarter. This quarter is starting. And by the end of the year, we plan on having nano silicone powder sent to laboratories and potential buyers. At the same time, in parallel, okay, because we will be learning, as we do the first phase, we'll be learning a lot, we'll be building a semi-continuous. That's what's gonna allow us the first really big scaling up milestone as we move forward. So we're working these 2 pathways in parallel. So basically we're doing the first batch process, secondary is semi-continuous process. What does that really resemble going forward? Well, this is what it looks like. If you remember the first slide at the beginning, this is our scaling up pathways for this process. So we've done the proof of concept. Phase 1, our old Gen 2 QRR is going to be converted to a brand new machine, which is a bench test Gen 1 nanoreactor. Okay, they'll have a capacity to produce 30 kilograms per month. more than enough to supply samples to many, many manufacturers and everything else. That's going to be very good. Once we start scaling up, once we have the Gen 2, which is going to be just by the fact that we go from batch process to semi-continuous process, we'll increase our production to about 30 kilogram per month. But there's a good chance that by the time we finish all the design, that might be more than 30 kilogram per month, might be 300 kilogram per month. So we're going from 30 to 300, but that might be 500 kilogram when we finish all the design. We don't yet. The preliminary math is really designed in that regard. So go make the math of 30, and I'll let investors do that calculation because I'm not allowed to do it. But right now that material sells for insane prices, and $30,000 or more. If we make 30,000 kilograms a month, it's a very interesting little market for us to deliver sample. Could be an interesting market. But we already have a pathways because we know the moment that we can start to demonstrate from phase 1 and phase 2 that we can do this, people are going to asking us for higher volume, okay? It's not going to jump from 0 to 920,000 metric tons per year, but you have to have a plan where you can, how you're going to meet those demands. Let's say if demand is there. Well, we have a plan all the way to going to 200 metric tons per month. So we're pretty advanced in our thinking. When you work with PyroGenesis, if you don't have this target, this feasibility to showing it, Pyro is not going to be interested. I think Peter has said it many, many times. It has a pathways of his business strategy, and this is what we're implementing and developing into it. So really, it's what we're talking about. We have a pathway to go up 200 metric ton. And what our plan is always, once we got the Gen 4 system, then we just copy and paste and multiply those systems. So in conclusion, with regard to our PUREVAP technology, we have an ace in the hole, which is the PUREVAP QRR, which allows us always to be the cheapest producer of silicon metal as feedstock. Why is that important? Every one of my competitors, every one of the competitors in the nano silicon business, okay, buys their silicon metal as a raw material, okay? At the beginning, that can be profitable, but we've seen it in the solar industry, all right? We've seen it in polysilicon. At one price, it is going to be a price war. And HPQ and PyroGenesis, from the get-go, we understand that this is a price war. We don't want to say how cheap we can do it, but we can lambada like you won't believe. We can really go cheaper than anybody else. We understand that our material that we're building, the nano silicon that we're building, has to be replacing graphite. Graphite sells for between $10 to $20 a kilogram. Battery manufacturer will not be willing to pay more than $30 to $50 a kilogram for that material. That's our base case of study, and I can tell you that we're darn profitable. Our internal studies indicate at $30 a kilogram, we're very, very profitable. We've, since the beginning of these research and our work that we've been doing, our point is to be cost competitive toward graphite with a much better product. So that's really what it is. And all my competitors are trying to develop process. They're all trying to get their cheap silicon from different areas. So if you develop a process and you partner, let's say, with a global specialty metal, well, at the beginning, they might not be interested in your business because it's too small. But as it's going to grow, they're going to squeeze on you to basically get their hand into technology. We can't be squeezed because we always can produce our own material. We'll always win the competitive war. So why I'm not rushing the development of the QRR is my ace in the hole for when we get the nano reactor moving. But we will be developing and moving it forward. Next slide. What are we doing? Okay, we're also working with Apollon Solar in France. And that's really another one of those serendipitous events. We realized that through our discussion, our years of basis of working together, that they had a patented process to making porous silicone, to make nano-porous silicone material. And that could also be another material that's going to be very interesting to meet the 900,000 metric ton of demand coming along. So we're working with them. I understand that the original agreement, supposed to end of June, and there'll be a renewal. If you look at our history, the way we've always worked with Apollon is we always ended up renewing and everything else. So if there was no renewal, if we were on the pathway through renewal, I would have issued something, but we're on a pathway to renewal. So just so people ask themselves questions, like if you look at the reality, often we announce the signature after the beginning of the month. So it's just the timeline of everything else. An AGM happens at a specific time. And it doesn't happen in the, it's not the same way as, you know, designing a contract. You don't plan an AGM for contract. You work on what you're working, and then the AGM just sort of happens. So really, Apollon Solar is really doing a lot of development. We have a 3-year experience working with them, so we feel very comfortable where we're going. What's their process? Well, that's really key. They design a process to make porous silicon production based on electrochemical anodization of a low-cost metallurgy wafer. So the beauty of it for the nano size is they already can make it very, very small. If you look at the particle size distribution, we're talking about between 2 nanometers and one micron. So it's the vast range. So we can produce a lot of material in the range that people are wanting to. It's just that the scalability of this process is not as fast as the one we're going to be having with the nano reactor, but this could be a very exciting material. So I'm not putting all the company's eggs in one basket. I'm doing multiple process. Porous silicon metal can have their own exciting markets and other differentiation. So just being able to talk about this will attract interest in what we're doing, and it's starting to move. So basically, to get that straight, we're talking about always our PUREVAP silicon metal. We go through steps that were basically coming out of the solar industry. This one is a bit more complicated. It's not really complicated. It's the only one we're going to have to basically work the scaling up. Then when you do the wafer and you break them down into the powder. So basically, what we're working with Apollon is restarting the lab scale anodization capacity. So we're talking about a capacity of 1.5 kilogram per month. So you see, it's not the same thing. Even our smallest machine is 30 kilogram per month, and we're going to scaling up to 300. There might be a feasibility scale of the 15 kilogram per month. So that might be something, something else, but there might be building a business case for a larger production capacity. And we're working a few ideas between Apollon and ourselves on that regard. So really, this is the pathways. We're restarting now. We're going to be producing batches, first batches, and figure out how we can increase yield and everything else, and design everything. So this is the indicative project pathways for this project. So why invest in HPQ? And then we're going to open the floor to questions. I'm pretty sure there must be tons of them. Or I put everybody asleep and everybody disappeared. I don't know, Patrick. Only 2 questions so far. By the way, I did get some email questions, but I knew I was going to answer them in the presentation, so I saw it there. So why invest? Okay. Basically, UBS estimates that over the next 10 years, the energy storage market in the US could grow to as much as $426 billion. So the numbers are everywhere, okay? And there are many ways to buy into the surge, okay? And the fact is, HPQ Silicon is an investment opportunity to participate in that surge. And what basically reduces the risk of an investment in HPQ is not, even though I know we're good, the fact that our technical partners are world leaders, and we're working with PyroGenesis, and I think people should understand that over the last few years, PyroGenesis has demonstrated a track record of being able to deliver on what they said they were going to do, which was game-changing technology. So that really plays into it. We're getting ready to go live. We're going to have nanoscale spherical SI powders and nanowires ready during this year. And the potential is already attracting interest from a lot of people, and there's going to be a lot more. I am, my experience is the moment I announce I start having samples, there's going to be more and more coming in. So we're going to be producing also high purity nanoporous silicon wafers to have them tested and developed. Porous silicon wafers for solid state batteries could be another way. We're producing 1 to 4N. So basically this year, we'll be sending a sample to research center and potential end user. And, we feel very comfortable, PyroGenesis and us feels very comfortable. We'll be in a position to deliver on those promises. That's really what it is. The other interesting, yes, our share price performance. A lot of people basically ask themselves a lot of questions. I know, and we could extend this 3 years. I know we look like we're zombie companies, or basically, basically barely alive. And interestingly, if you look at the companies I put below, our companies are involved in the same business that we are. So basically, the top part of this presentation is our share performance. When we started to move up, I don't know if there's a relationship, but it was also at the same time when PyroGenesis started to move up. I think the credibility that PyroGenesis has now at delivering the good is basically attracting interest in what we're doing. But at the bottom, in the same time, where we were not having any pulse, nobody else was really having any pulse. Last year, there was a bit of a buzz. This was cobalt, so basically all related to energy storage. Okay, but everybody's there. The other ones are you have yeah, that's cobalt. This is lithium. This is rare. This is recycled rare earth. Those are two graphite play. Okay, and every one of the graphite play, you'll be, if you listen clearly to what they're saying, is we now need to go make high purity materials for the battery space. So it's not even their mine anymore. I think just today I saw a press release from Nouveau Monde that they're going to spend another $1.5 million, the government grant, to do R&D to make, you know, material for the battery space. So their mine cannot succeed without this. We've already figured out that, you know, it's the end product that differentiates everybody. I know, and I've heard often the criticism of Quebec-based technology companies that have done everything, but I've studied most of their error. And most of their error has always been, one of them is, A, they're trying to develop alone. So they go from university professor to a technology. We're working with PyroGenesis, which has a track record of going from a pilot scale, you know, basically a desk stage project all the way to a to commercial scale. So that already mitigates the risk. And the second one is we're in the nano-powder, which is an area which PyroGenesis has a lot of expertise. So just the point I wanted to say is, although our performance looked bad over the years, during this time, we did not waste our time. Our QRR technology is our hastening goals, which is going to differentiate us from everybody else. And I think it's just the beginning. I seriously believe that, you know, we should have been priced at this level for a longer time, but it's only now the market's realizing this. I strongly believe that what we have in our hand is unique, and hopefully it'll start reflecting itself in the share value. And I'll now have a good story to go tell the industry. Other key point for people that keep asking me also, so okay, so what's our cash position? Well, the increase in valuation has completely changed. If you look at a 52-week high, we had 4.5 cents. We went to 21. So we're last one, when I did this was based on last Friday, 41. What that means is we have about 900,000 in cash and cash equivalents. So that's our cash. That's our shares in PyroGenesis, and that's our shares in Bose Goldfield. And we also have $10.3 million worth of warrant in the money. What that means is we're in no rush to do financing. Most of the QRR R&D and research is already prepaid and pre-financed, so we'll have $1.9 million in prepaid. And the rest for the nanoscale reactor, that we have a good plan with PyroGenesis to get that moving. It'll become public, it'll become clear very, very soon. So we're not really worried about it within our cash position. Now, for some people that might be worried about the size of the warrants and everything else, I just would like to remind people that about 70% of those warrants are controlled by 4 different groups. PyroGenesis, the Quebec government, insiders or board, and investors very close to us. And if you look at the timeline, they're scaled over the next 3 years. They're not coming all due at the same time. So I dare to say that the only warrant series that is widely held is the November 2020. It's already started to be exercised. So basically, this is what it is. Management and board, you know, we've already voted for all these things. You know, PyroGenesis is at 9.8%, 14% fully diluted. Investissement Québec is 9% fully diluted. Strategic investors, that's Apollon Solar. And key investors are basically people that are very close to us. So this is consultant, trading, transfer, and agent, and you recognize 2 of our faces.